Yes, Ajahn.
Morning, teacher. Yes.
Okay, can you see my slide?
Yes, sir.
Okay, okay. Ah, okay. Can we continue from the previous lecture? Okay. In the previous lecture, I teach you about the property of the main property of the Fourier series. Okay. Generally the property is already summary in the table form. Okay. And now the last one. Okay. The idea to use, okay, the idea to implement the Fourier transform in the real application. What about that? Okay, I will present them roughly in the last section this year. Okay, the Fourier series and the linear and the time invariant system or the LTI system. Okay, if the input signal is here, the system that you have or you would like to process or to manipulate the input will be LTI system here, and the output in this case is here. Okay, if the input is already in the sine wave, you can see that is 1.5 cos function and the sine function. Okay, okay. In this case, if you write them or you get xt in the form of time domain, you don't see anything clearly, right? But if you get them in frequency domain, okay, by use the Fourier series expansion, okay, you know that you can express them here. The rectangle 1.5 data is here, okay, and okay. 2 cos, okay, cos is okay, cos 2 omega and cos 3 omega is here, okay, 2 cos and 3 cos is here. Okay, now, okay, when you expand them in the Fourier series, will be expand by here, okay. This impulse, the middle impulse represent to 1.5, okay. The next two, okay, is represent for the 2 cos 2 omega t, okay. And the last one is, okay, the last impulse, the last pair of the impulse will be present for 4 cos 3 omega. If we send this signal to the system, and in this case, if the system is about a filter, okay, but the filter have different amplified range, okay. In this case, you can see that if the frequency is higher than 2.5 omega naught, okay, it will be cut off all, okay. This filter is some kind of the low pass filter, okay. So low pass filters. It means if the frequency higher than 2.5, it will eliminate all, it spread all, okay. But if the frequency is higher than 0.5, okay, to this range, okay, it allows the signal to pass untouched, okay. The magnifier will be 1, okay. And if the frequency is lower than, okay, is lower than 0.5 omega, is amplified by 2 times. Okay, now what happened? Okay, I think if you get xt in the time function, you don't know about the relationship of them, but if you get them in the frequency domain, the way to determine the way to find the relationship between the output that generate from the input and the impulse response is very simple. Okay, for the LTI system, the output equal to the convolution of the input and the system in time domain. But in the frequency domain or in the Fourier series domain, it equal to a simple multiplication between the system function and the Fourier series or the Fourier transform. In this case, you can see that when you see in this case, you can see that, okay, the signal that you have is comprised by the 3 frequencies range. The first one is 1.5, is mean the 0 frequencies, okay. It's already in, okay, it will be magnified by 2 times from the system that you have, okay. Okay, at the medium frequencies, okay, it will be allowed to pass untouched, okay. It's no magnified, but it don't attenuate them, okay. And the last one, okay, at the frequencies highest, okay, at the frequency highest, okay, the system will be spread out. Therefore, in this case, okay, the frequencies of 4 omega, 4 cos 3 omega will be 0, okay, spread to be 0. And for the middle, it's the same, okay? And for the lowest frequency, it will be amplified by 2 in 1.5 to be 3, okay? To be 3. You can see that at the middle, you allow to pass, okay? To pass untouched, okay? This is the result of the frequencies of the Fourier series of the YT, okay? That generate from this system. Now, we show you another one example that we frequently found in the real application. If we have the input, you have the LTI system again, and this, okay. The system have comprised by about 4 frequencies range, okay. At the 0 frequencies, okay. At the omega frequency, 2 omega frequency, 3 omega frequencies, okay. At different magnitudes, okay. Yeah. The system in this case, the system is more practical than the previous. It's the same as the low pass filter, but the first order low pass filters. Okay, if the frequency is close to middle or close to zero, okay, the magnitudes or amplifier of the low pass filter equal to 1, close to 1. The higher frequencies of the component is, okay, the lower attenuation of them is, okay. In this case, when you see that, okay, the signal when you multiply between the input frequencies and the system function, you see that when the frequency is higher, it will be attenuate more and more, okay. Therefore, the result in this case, you can see that as the frequency is higher, it will be the result of the YT will be very low one. But if for the frequency is low, for example, at the frequency at the 0, okay, is here, is 1, it will be allowed to, okay, it's allowed to pass untouched. It means it don't process anything. The magnitude of the signal will be amplified by 1 or don't do anything. Yeah, it's about the real application of the Fourier series that you can find in the engineering application. Okay. Okay, this okay is overall for the this part. Okay. Okay. Next one. Okay, the Fourier series all is that. Okay, now is here. We go to the next chapter, the Fourier transform. Even though the Fourier transform is not accessed in the midterm, but it will be accessed in the final. Okay. Oh, and the one last thing, everyone know that, okay, the university already announced that, okay, you must take the online exam for the midterm. Okay, the online exam will be present in pass through the Microsoft Teams. Okay, everyone must have the camera to identify yourself. Okay, and open the cameras at all time during the exam. Okay, and I will send the midterm question pass through the Microsoft Teams, and you will write the answer and you send them back to my email. Okay, to my email. I will tell you my emails. Okay, when okay at the exam time. Okay, clear? Anyone can hear that? Hello.
Yes,ครับ.
Okay. 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 We go to the Fourier transform. Okay. The next. Okay. The Fourier transform is another version of the Fourier series. Okay. But in this case, the Fourier series is a limit for the periodic signal. For the Fourier series, for the periodic signal, the Fourier series, or we call the continuous time, the Fourier series can be used to represent the signal as the linear combination of the complex exponential of the form E j omega t. Okay. But for a periodic signal, this chapter extends the Fourier series concept to apply to the aperiodic signal that have a finite energies. Therefore, the representation of the linear combination in the form of an integral rather than the summation is a spectrum of the coefficient. Therefore, the Fourier transform, also called the continuous time Fourier transform, will be present in here. The inverse Fourier transform or the inverse continuous time Fourier transform use this spectrum coefficient to represent the signal as the linear combination of the complex exponential form. Okay, we will start by the definition of the Fourier transform first. Okay, later we consider in the how to apply the Fourier transform for periodic signal. Next one is the property of the Fourier transform. Okay, the convolution, the multiplication. Okay. And the sum common Fourier transform pair, okay, analysis and the classification of the LTI system using the Fourier transform. For the definition of the Fourier transform will be present in here. We will develop of the Fourier transform representation for a periodic signal from the Fourier series. It means we extend the Fourier series idea that can apply for a periodic. How? A periodic signal you can use, okay, as a periodic with a finite and with an infinite series, okay, or infinite period. Okay, it means for the periodic signal, okay, the period of the signal is finite, right? Maybe 1, maybe 2, maybe 3, okay, that you already determines the Fourier series from the previous exercise, okay. You can determine, okay, omega naught or T naught, okay, and for the Fourier series representation of a periodic signal, if the period increase, then the fundamental frequencies decrease and the harmonically related complex exponential closer in the frequencies. Therefore, if the period become infinities, then a frequencies component from an continuums of an Fourier series sum become an integral instead. Therefore, if you try to extend the periods of the periodic signal from finite to be infinite, okay, the Fourier series will become the Fourier transform, okay. The idea of them I will present in the graph in here, okay. We consider about this signal, the continuous time periodic waveform xt with the period t is defined by here. You can see that each signal, the period of them is a t. You can see that xt is a periodic clearly. Therefore, you can find the Fourier series AK by use the previous definition of the Fourier series. Yeah. Okay. AK equal to this, okay, and we normalize by t, okay, multiply t at the normalization, okay. Now in this case, if we assume that t1 will be equal to, okay, is t equal to 4t1, 4 times of them, okay. TAT is about that, okay. If the the Fourier series for this xt, the red graph function is the red one. You can see that it's the discrete one. Okay, is A0, AK when k equal to 0, or A0, A1, A minus 1, A2, A minus 2, A3, A minus 3. You can see that, okay? Even though the Fourier series will be in the form of the sinks function, but the value of them is not continuous. It's not the green one. It's only the red one, the discrete, okay? And the number of the discrete value depend on the period of xt. How? I will show you if we expand the period, okay, one time, okay. In this case, if t instead, in this case, if we extend them, okay, t equal to x t1, a equal to x t1, what happened? You can see that the signal is time scaling, okay, time scaling, okay. You scale by 2, okay. You expand them by 2, okay. Therefore, in this case, what happened to the Fourier series? The Fourier series will be more denser. You see that if you extend the signal in time, okay, expand them, okay, the Fourier series will be more denser. If we extend them more, what happens? If we extend them to be infinity, okay. Now, therefore, the Fourier series will be exist at every point in the green envelope, or it will become here. Okay, it will become here. Therefore, in this case, if you extend the Fourier series to be infinities, okay, the period of them, you can see that in this case, we assume that one period for equal to infinity, the Fourier series will become the Fourier transform, clearly. Now, this about this idea. The idea that a periodic signal is the limit of the periodic signal with the period and become arbitrarily large. If the period t is arbitrarily large, then xt is identical to xt over a long interval of t. If the period 3 is infinite instead, then xt is definitely equal to xt for any finite value of t. From the Fourier series, the synthesis equation can define by here, okay, xt in the form of the Fourier series coefficient is about here. Therefore, AK we can determine from integrate one period of the signal. In this case, if the period of them is infinity, therefore the formulation of the AK will be changed, okay, change to be minus infinity to infinity instead, okay, and therefore we'll change the definition of the envelope x j omega, okay, will become here. All this equation is called the Fourier transform equation. Remember that, okay? The Fourier transform x j omega, okay, equal to the integrate from minus infinity to infinity xt e minus j omega t dt, okay? The Fourier series coefficient is defined by here, okay? You can see that it can define by ak equal to this Fourier transform, and you scale them by omega naught, okay? Scale them by t, okay? We can express the synthesis signal in the term of the Fourier transform as following here, okay? AK, okay, is here. You substitute them, okay? Is x j k omega naught, okay, divided by t. Okay, substitute them in the blue term or yellow term, we come here. And therefore, in this case, you extend them, you can simplify that, okay? Okay, omega will be here, okay, and 2 pi is constant. You can move them out from the summation operator, okay? In this case, we take the limit when t is reached to infinity. If t is have a limit of reached to infinities, omega naught equal to reached to 0. And the inverse Fourier transform or the Fourier integral of the xt is defined by this following equation, okay? This equation. Yeah, this thing is called the inverse Fourier transform, okay? Remember two equations. This four equation is Fourier transform. This equation is inverse Fourier transform, okay? The transform x j omega of a periodic signal xt is traditionally called as the spectrum of xt, okay? And the Fourier coefficient ak of a periodic signal x type can be expressed in the term of equally spaced sampling of the Fourier transform of one period of x time. And the convergence of the Fourier transform. There are two analysis methods for the convergence of the Fourier transform. The same idea, close same idea to the Fourier series, okay? We can use the Dirichlet tree condition. Do you remember? The Dirichlet said that we have three conditions that guarantee that the signal have the Fourier series or Fourier transform, okay? The signals, okay, and the convergent analysis from the derive them directly from the Fourier transform definition. The first is a convergent analysis from the Fourier transforms definition, okay? From the definition is here x omega, okay, equal to integrate from minus infinity to infinity, xt e minus j omega t, okay? And if xt is a finite energies, okay, and if xt is a square integrable, take square, you can see that you take square and you can integrate them. It's finite, okay, it's less than infinity. Then you can guarantee that the Fourier transform or x omega is guaranteed to be finite or exists. In this case, we state that x omega or the Fourier transform is converged, okay? Or it means x j omega can be calculated from the above equation. The second, the set of the conditions that are sufficient to ensure that the Fourier transform exists is the Dirichlet tree condition. The first one, okay, you said that xt be absolutely integrable, okay? You take absolute them and you integrate the signal, okay, in all range, okay, from infinity to infinity. It means the area under this class is finite. If it's finite, it means it's okay, it's satisfied the Dirichlet, the first condition. The second condition is here, the xt have a finite number of maxima and the minima within any finite interval, okay? The last one is the xt have the finite number of the discontinuity within any finite interval. Furthermore, each of these continuities must be finite, okay? If the signals xt satisfy this condition, the first or the second, then the signal have the Fourier transform. However, some signals are neither square integrable that broken or violates the first group of the condition, nor absolutely integrable over an infinite intervals. The first group of this condition, the signal can be considered to have a Fourier transform if the impulse response or the impulse functions are permitted in that transform, okay? In order to give you more understand about the Fourier transform, I will show you how to compute them, okay? Determine the sketch the Fourier transform of this following function, okay? Yeah, okay? E minus AT is the decaying exponential. Multiply with the UT for time greater than 0. Okay, the signal is equal to 0. 0 multiply anything give you 0 too. Therefore, that's why XC will be 0 for time greater than 0. And for time greater than 0, okay, XT equal to E minus AT. E minus AT, decaying exponential. Okay, from the definition, the Fourier transform of the continuous functions is given by this equation: x omega j omega integrate from infinity to infinity xt e minus j omega t dt. Okay, dt. In this case, after you get the signal, you will know about the suitable range for the integration. In this case, the range of the integration separate from infinity to 0, 0 to infinity. From infinity to 0 is equal to 0. Okay, therefore, the integration will be reduced from 0 to infinity instead, because the value, the xt that lower than that, okay, lower than t equal to 0 will be 0. For time greater than 0, xt equal to e minus at, e minus at. Okay, you can group that, okay, eat, integrate EAT give you EAT divided by A. Yes, EAT divided by A. And you substitute the range of them from infinity and from 0. Okay, from infinity, anything power minus infinity equal to 0. Okay, you can eliminate them and this thing. Okay, anything multiply 0 give you 0. And anything power 0 give you 1. Okay, that's why it's become 1 in here. It's 1 minus 1 in here. Therefore, in this case, the Fourier transform in this case equal to A plus j omega. It will be in the functions of the omega instead of time. Okay, because the Fourier transform of this function is a complex value, we traditionally plot x j omega in the term of the magnitudes and the phase instead. Okay, now generally, in the real application, we physically plot them. You maybe plot them in the magnitudes or magnitude square and in the angle or in the phase. Okay, the magnitudes or magnitude square will become here. Okay, decaying after that, and in this case, you can see that if the omega is higher than in the left hand, it has the maximums. Yeah, sorry. Okay. In the left hand, in this case, you can see that the Fourier transform of them, okay, will be performed right, the low pass filters. Okay, when the frequency is higher than A, okay, lower than minus A or higher than A, it means, okay, if the frequency is higher than absolute A, it means the frequencies, the magnitudes of them will be dropped a lot. Okay, but if the frequencies between lower than 0 to A, okay, in this case, the magnitudes of them, the amplitude of this filter will be close to 1 divided by A. Okay, and the angle phase will be minus arctan is omega ya. Okay, what about this magnitudes of the phase angle of them? You can plot them is about here. Okay. Next one. Okay. Determine and sketch the Fourier transform of the signals x absolute t is here. You see that? In this case, the function will be separated into time from infinity to 0 and 0 to infinity. Okay, you split them into, okay, one is the ut in the right hand side, one is u minus c in the left hand side. Okay, two functions. Okay, it differ even though you seem them to be a single function, but the real one is not. Okay, it's comprised by the two mathematics form differently. Okay, one is the ut, one is the u minus t. Okay. You integrate them the same as the previous. Integrate the exponential, you try to grouping them. Okay, you grouping them e something t. Okay, okay, c power, okay, e power at or alpha bt or alpha t. Okay, and you integrate eat, give you eat divided by a. Okay, yeah, you integrate eat equal to eat divided by a. Okay. And after that, you substitute the range of the integrations from infinity to 0. Okay, from infinity to 0. Okay, this thing is infinity. Anything power infinity is a 0. Okay, power infinity is a 0. This thing, okay, power 0 give you 1. Power give you 1. This power 0 give you 1 too. Okay, you multiply them, give you here. Okay. Because the Fourier transform of this function is a complex value, we traditionally plot the Fourier transform in the term of the magnitudes and the phase instead. Okay, the magnitudes of them will be in the form, okay, 2b divided by b square omega square, and the angle in this case, okay, the Fourier transform comprise only the real part, therefore imaginary part 0. If it have no imaginary part, or imaginary part is a 0, the phase of them is a 0 too. Okay, the magnitudes response is a b square is here divided by 2b divided by b square plus omega square. Okay, and the phase of them will be 0 in orange. Okay. Next one, for the delta functions, okay, determine and sketch the Fourier transform of the function xt equal to the delta function. From the definition, the Fourier transform of the continuous time is given by here. You see that substitute the data function in them, okay, integrate the data, indicate the impulse function from an infinity to infinity. From the data definition, it gives you 1. Therefore, from the Fourier of this function is a complex number. Okay, in this case, the magnitude is equal to 1. It means it's flat in here. Okay, and the phase is due to the magnitudes. The Fourier transform is comprise only the real part. Therefore, the phase of them is a 0 everywhere. Okay, due to no imaginary value, the phase of the xt or the Fourier transform xt is 0. Okay. Okay. Can I stop for a while? Okay, now it's your turn. Okay, take it. Okay, take it. Can you capture this? Okay, and I give you 15 minutes. Okay, do it. Okay, and write your answers. Okay, you captures. Okay, maybe use the camera to capture your answers. Post it in the meeting chat, and I will checking everyone. Okay, everyone. And one last thing, turn on your camera now. If you don't turn on, any student don't turn on the camera, your attendance is not graded. Okay, can you see this? Capture the practice one. The practice one is already in, okay, if you have the book, it's the first question, okay? The first question in these chapters, okay? In the practice section. Okay, capture them clearly. Let's do it now, quickly. Yeah, and I will present the next exercise letters, okay?นัชชยาเจอกันอีกแล้วเราลงวิชานี้ด้วยนี่นะใช่ไหมชนิสานี่ตั้งกล้องไปที่ไหนเนี่ยเห็นแต่หลังคาCanisia. Oh, sorry, Canisia, right? Yeah, I see your face now. Okay. รัชตะวันใช่ไหมโอเครัตพลหน้าตายังไม่ตื่นเลยเอาขยับกล้องหนีเลยเอากล้องไปจี้แสงเลยเหรอเอารัตพลไปไหนแล้วตื่นยังสุพนัทเป็นไงบ้างกี่รอบแล้ว2 รอบรอบนี้เอาให้ได้ดับเบิลคิวนะเว้ยเอา A เลยนะชนนิการนี่ก็เจออีกแล้วลงอิมเมจดีกว่า Okay, if you already finished, okay, you use your smartphone or maybe captures the okay and okay and post this in the meeting chat. Okay, and I'll be checking that the thing that you do is right or wrong. Okay.นาราวิชเป็นไงบ้างใช่ไหมนาราวิชโอเคนะอะไรเนี่ยแพนวิงยี your camera is don't show your face okay I can see it okay what about is pronouncing NIY นิน
Yes, อาจารย์
นิน right hello is
Hello,
pronounced
can you-
นินMYO what about is pronounced
Yeah, it's Mio.
เมียวโอเคนินเมียว right
Yes, อาจารย์
but I use my what did we owe the question is too easy okayว่าไงชื่ออะไร Prince เหรอ Prince หรือ Prince ยังไม่ได้เปิดเสียง Prince ใช่ไหม Prince แปลว่าอะไรอ่ะอย่าบอกนะตั้งชื่อว่าแปลว่าเจ้าชาย
อ๋อไม่ใช่ครับปรินครับปริน
อ๋อปริน
แต่ความหมายก็ไม่รู้เหมือนกันครับ
อ้าวเฮ้ยชื่อเองนะเว้ยความหมายแปลว่าอะไร
Google แป๊บนึงครับ
ปิยธิดาทำไมไม่เปิดกล้อง
เปิดแล้วค่ะอาจารย์ไม่เห็นเหรอคะสักครู่นะคะเนี่ยค่ะหนูเปิดแล้วอะค่ะ
โอเคเช็ค
เดี๋ยวหนูเปิดอีกเครื่องหนึ่งก็ได้ค่ะ
ไม่เป็นไรเดี๋ยวดูสิเนี่ยธิดาซึ่งที่มันก็ไม่ขึ้นเนี่ยไม่เห็นขึ้นเลยนะไม่รู้มันเป็นบั๊กหรือเปล่านะแต่บางคนก็ขึ้นนะคนก็ไม่ขึ้นเห็นแล้วปิยธิดาฮะโอ้โหนี่ยังเรียน outdoor เลยเหรอเนี่ยมีต้นไม้ด้วยต้นมะม่วงวะเนี่ยไม่ได้ยินเสียง
เรียนอยู่หน้าบ้านค่ะอาจารย์
อ๋อนึกว่าแบบโอ้โหติดมากเอาโต๊ะไปตั้งใต้ต้นไม้เรียนเลยอะแบบ
อ๋อไม่
แซวเล่นไม่เป็นไรหรอกนั่งตรงไหนก็ได้ไม่เป็นไรหรอกนึกว่าแบบแหมทำเป็นแบบนะอะไรนะนักข่าวเดี๋ยวนี้เลยแบบโหเหตุเกิดที่ไหนไปนั่งตั้งโต๊ะตรงนั้นได้เลย Oh, anyone finish yet? Mhm. Mm. first one is current.รัตนพลได้ยินไหมฮัลโหลได้ยินไหมเอ่ยรัตนพลใช่ไหมส่งมาแล้วนี่คนหนึ่งใช่ไหม
ไม่ยิน
อินดิเกรต3อยู่คนไทยหรือเปล่าเอ่ย
ใช่
คุณอินดิเกรตเนี่ยคือเวลาอินดิเกตเนี่ยมันไม่ต้องใช้ลบที่1นะในตัวอย่างมันลบที่1มันเป็นกันอันนี้ก็คือคุณแทนค่าไปเลยอินดิเกตจากเท่าไหร่
จาก10 กับ 0
จาก0ไปที่10เลยนะจาก0ไปที่10แล้วแทนค่าเข้าไปเลยโอเคนะไปแก้ซะไปไม่มีอะไรแต่ก็ดีแล้วถ้าคุณไม่ทำมาผมก็ไม่รู้ว่าคุณต้องทำอะไรเพิ่มนะเขียนมาตอบมาสุบนัทยังไม่เสร็จอีกเหรออินดิเกตแค่นี้ยังไม่เสร็จอีก
ใช่แล้วครับ
โอ้โหลงรอบ2แล้วมันต้องเสร็จก่อนน้องๆแล้วแต่ชินอารมณ์ล่ะเสร็จยัง
กำลังเช็คคำตอบอยู่ครับ
แล้วชนทิชานี่เสร็จยังเนี่ย
กำลังเช็คใหม่ค่ะอาจารย์
ทำไม
ตรงไหนก็ไม่รู้
มีคิดใหม่ด้วยเฮ้ยไม่ใช่หาคำตอบไม่ใช่เลือกแฟนไม่ต้องคิดใหม่นาน
อาจารย์คะคือเราใช้ตอนเราอินทิเกรตค่ะเราใช้0 ถึง 10ได้เลยใช่ไหมคะหรือว่าเราต้องใช้ตัวทีหนึ่ง
ก็คือจริงๆเวลาคุณอินทิเกรตจากลบอินฟินิตถึงอินฟินิตนึกออกใช่ไหมแต่คราวนี้เนี่ยฟังก์ชันเนี่ยมันแบ่งเป็น3ส่วนถูกไหมจากในกราฟเห็นไหมได้ยินไหมเอ่ย
ได้ยินค่ะได้ยินค่ะ
ก็คือฟังก์ชันเนี่ยมันแบ่งจากลบอินฟินิตไปจนถึง0นึกออกไหมค่าตรงนี้มันมีค่าเท่าไหร่เท่ากับ0ใช่ไหมแล้วก็จาก0ไปจนถึง10มันมีค่าเท่ากับ3นะแล้วก็จาก3จาก10ไปจนถึงอินฟินิตี้ใช่ไหมเพราะฉะนั้นเนี่ยก็คือ period มันก็คือจะเป็นพาร์ทแรก
เป็น10ใช่ไหมคะ
จะเป็นค่าที่อินดิเกตได้เท่านั้นเองนะโอเค Again, okay, if you ask in Thai, I understand that I will answer in Thai, but don't worry about that, okay? But what about 0000? Ping Summit, you touch the keyboard or something like that. Therefore, it have so many zero in the meeting chat.
Damian, teacher call you.
Yeah, sorry, the keyboard.
Yes, I think because I said maybe you have any question in the meeting chat or something like that. Okay.
Oh, I will ask.
He want the score in midterm.
No, sir.
Okay, don't worry about that. Okay, try to do that. Okay, try to and you will when you post your answers. Okay, I can fit your answer, your idea. The same that in the class. Okay, in the side when I teach on side. Okay, I will force every student to take the exercise, and I can see that. Okay, the thing that you do is right or wrong. If it's wrong, I can fix your idea now. Okay, quickly. Hmm?
คือคิดได้แค่นี้แล้วมันคิดยังไงต่อได้อีกไหมมันคิดต่อยังไง
มันคิดต่อยังไง เดี๋ยวไปนั่งคือ เทอม e ลบ10 j โอเมก้าเนี่ยจริงๆมันมีวิธี modify เพิ่มนะแต่ว่าเดี๋ยวจะบอกในสไลด์อีกทีนึงเลยนะเราไปนั่งนึกดูว่าจะทำยังไง1กับ e ลบ10โอเมก้าทำยังไงให้มันเป็นไซน์เป็นคอสนะนั่งนึกแต่ก็โอเคแล้วได้ขนาดนี้ก็ได้80-90% ละชิมลงOkay, it's right. Chitnalom is okay. Supanan. Okay. For language. Okay, language is okay, but if you can simplify more than this, okay, it's better. Okay. She Tun is okay, it's right. Okay. Pattaranan. Pattaranan is okay. พัฒนานันเรียนด้วยเหรอนะพัฒนานันเรียนด้วยเหรอเรียนกับผม2 วิชาใช่ไหมเรียนอิมเมจด้วยป่ะ
ใช่ค่ะ
โอเคพวีโอเคพันวิทยี is okay is right โอเคชนิกา is okayโอเคนัชชยา is okay รัตพลโอเค รัตพลอยู่ไหมเนี่ย
อยู่ครับ
มันไอ้กล่องบรรทัดสุดท้ายนี่โอเคไอ้บรรทัดสุดท้ายนี่มันไม่เท่ากับนะมันเท่ากับไซน์5 โอเมก้าเลยเหรอไปเช็คดูดีๆ
อันนี้
ก็อยาก simplify แต่ถ้า
คือเปลี่ยน
simplify
ไม่ถูกค่ะ
นะเดี๋ยวโชว์ให้นะถ้า simplify ไม่ถูกอย่าไป simplify ถ้าพยายาม simplify ให้มันผิดมันจะสวยนะก็จะโดนหักคะแนนไปแต่ก็ไม่เป็นไรมันก็ค่าเท่ากับได้ 80-90% ตรงนั้นมันก็ได้ประมาณนั้นแหละลองดูนิดโอเคนิดเหมียวใช่ไหมโอเคนี่ใครรัชตะวัน okay รัชตะวัน is correct one okay Okay, you can see that the exercise that I order you to do, if you don't do and you sleep, I cannot help anything. But you can see that if you try to do that and you post in here, I can comment it to you, okay, right now, okay, it's right, it's wrong, check this, okay, for the last one or so on, okay, that is already confirms your idea, okay. Okay, if you finish the first one, okay, you do the second one, okay, the second question, okay, and the next time I will provide the solution for the second one, okay. Okay, for the first one, I give you another 2 minutes, okay, and I will provide your solution, complete solution with explanation.ปิยทิยานี่อยู่ที่กรุงเทพปะเนี่ยหรืออยู่ต่างจังหวัดเลย
อ๋ออยู่ตอนนี้อยู่นนทบุรีค่ะ
อ๋ออยู่นนท์ยังว่าอยู่บ้านสวนยังว่าอยู่ว่าในกรุงเทพบ้านที่มีต้นไม้เยอะๆมันยังเหลืออีกเหรอยกเว้นนะเองต้องแบบอยู่แบบคฤหาสน์มากหรือมันก็ต้องเป็นบ้านเก่าแก่มากถ้าจังหวัดนนท์ก็ยังมีสวนอยู่เยอะปลูกอะไรบ้างล่ะไม่ได้ยินเสียงเลย
ค่ะค่ะอาจารย์ได้ยินหนูไหม
ปลูกอะไรบ้าง
พูดว่าอะไรนะคะอาจารย์หนูไม่ค่อยได้ยินเลย
สวนเราบ้านสวนเนี่ยมีปลูกพืชอะไรบ้างผลไม้อะไรบ้างเหรอหรือไม่รู้
หนูเห็นแค่มะม่วงเนี่ยแหละค่ะ
เปล่าก็เลยจะบอกว่าอย่าไปตั้งใต้ต้นทุเรียนนะหล่นใส่หัวเดี๋ยวได้เกิดใหม่พอดีคิดในแง่ดีปลูกบอกว่าปลูกแอปเปิลเยอะๆเผื่อแอปเปิลตกใส่หัวจะได้ฉลาดเหมือนเซอร์ไอแซคนิวตัน Okay, I will provide the solution for you. Okay, the solution of the first question in detail. You can see that when you see the question. Okay, when you see the question and I provide your solution, it's very easy. But when you do by yourself, sometimes it's not clearly easy. Okay, you can see that in this case. Okay, from the definition, the questions ask you use the Fourier transform definition equation. Therefore, you cannot use the table. Okay, you must use the definition. Okay. You from the definition, okay, the Fourier transform is integrate from minus infinity to infinity xt e j omega t is here, right? For the xt in this case, it's separate in three range. Okay, the first range is integrate from minus infinity to 0, and integrate from 0 to 10, and integrate 10 to infinity. But the first and the third range is equal to 0. Okay, we can omit them. Okay, therefore in this case the range of the integration reduced to be 0 to 10. Okay, and okay, after that, okay, 0 to 10. Okay, integrate t EAT. 3 is a constraint, you can move it out. Integrate EAT, it gives you EAT divided by EAT divided by A, and substitute the range from 0 to 10 for every t value. Okay, 0 to 10 is here. When you substitute 0, anything power 0 give you 1. Okay, give you 1 is here. You organize the equation, bring you here. Okay, if you can answer this, is okay. You get maybe 80 or 90%. But in this case, if you see a little bit 1, okay, is have E minus j omega 10. Okay, you can multiply. Is minus j omega is here and this here is 5. You split 5 in here. Okay, after you move with E minus j omega 5. Okay, it bring to be here and here, and E j omega 5 is here. You can reorganize the form to be the trigon form. Okay, this thing is E plus j omega 5 minus E minus j omega 5. Okay, it's a size cos. Okay, it's a sine function. Okay, sine function, you will bring it here. Okay, divide by 2j. Divide by 2j. Okay, it's a sine. And divide by 5. Sine t divided by t give you sinc function. Sine t divided by t give you sinc function. It is a core form that you can bring and you can get from this equation. Okay. Clear? You can see that when you do by yourself, and when we show you the detail, is very easy. Okay. And now for the plottings, the magnitudes of them, okay, determine get the magnitudes of them. The magnitudes is here. Okay. The magnitudes is have 3 terms. 30 is constant. E minus j theta. E minus j theta is equal to 1. The magnitudes of them equal to 1. Okay. The sinc function, the magnitudes of the sinc functions, okay, will be here. Absolute of them, okay, make them the okay, negative, make them positive is here. Okay, the absolute will be here. Okay, the next one is here. The second one, okay, you take the exercise and try to do them. I will give you a solution in the next time. Okay, okay, this class maybe is okay, finish faster than the schedule. Okay, if I will waiting for the second question, I think is 5 minutes is not enough. Okay. 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 For this lecture will be okay. It's finished now. Okay. Now try to take the second and the third by yourself. Okay. The second question and the third question, I give you only 2 assignments. Okay. 2 assignments. Do by yourself. And the next time I will provide your solution. Okay. Any question? Due to I know, okay, how to handle, okay, you may have the questions, okay, why maybe 2 or 3 weeks before I don't assign you to do the exercise, because I try to find a way to communicate with you until I try to see that, hey, it have the meeting chat that you can send some solution to me, to grading, to checking that. Okay. Okay. If you don't have any question, okay. Okay. We have another. This is the last part, right? You have the exam 7, right? I'm not sure.
Ajahn, this chapter is not in midterm, right?
Not midterm, not midterm.
Yes. Okay.
เราสอบวันไหนนะ
ตั้งแต่11 ถึง 20 ค่ะอาจารย์
เดี๋ยวดูตารางสอบสิตารางสอน general calendar เอา11 ถึง 20เพราะว่าก็ยังมีคลาสอยู่ก็เจอกันอีกทีวันที่ 7 ใช่ไหมโอเควันที่ 7 นะโอเค is okay therefore you still have the class okay another one class in the 7 right Thursday okay
That can you do review on 7?
huh
Review.
Review?
Yeah.
You want to review? Depend on you. Okay. Yes. When we have, but we have the class at the 7. But which class? Maybe you maybe request it. Okay, at the time. Okay. Maybe a review for the midterm. Okay.
Yes, sir.
Okay. We will vote at that time. Okay. Good luck. See you next time. Okay. Dismiss. And be careful. May the force be with you. Okay. For prevent from the COVID. Okay.
Thank you, John.
thank you ครับอาจารย์
Yeah. Happy New
Thank you
Year.
อาจารย์
Okay.
See you อาจารย์
Thank you อาจารย์
You're
ขอบคุณ
welcome.
ครับ